अब हम केंद्रीय लोक निर्माण विभाग के 168वें वार्षिक दिवस समारोह के दूसरे चरण यानी टेक्निकल सेशन की शुरुआत करते हैं। मैं दीपाली मिश्रा, आर्किटेक्ट, परियोजना क्षेत्र दिल्ली, एक बार फिर आप सभी का स्वागत करती हूँ। वर्तमान युग विज्ञान और टेक्नोलॉजी का युग है। आज कोई भी क्षेत्र ऐसा नहीं है जहां टेक्नोलॉजी और आधुनिक उपकरणों का इस्तेमाल नहीं किया जा रहा हो। टेक्नोलॉजी ने न सिर्फ मानव जीवन को विकास की नई गति प्रदान की है, बल्कि उसे सफलता की नई ऊंचाइयों तक पहुंचाया है। सर्वप्रथम आज के टेक्निकल सेशन में हमारे बीच उपस्थित आदरणीय महानिदेशक केंद्रीय लोक निर्माण विभाग श्री शैलेंद्र शर्मा जी, विशेष महानिदेशक प्रोजेक्ट रीजन चेन्नई श्री राजेश कुमार कौशल जी, विशेष महानिदेशक इंजीनियर इन चीफ PWD श्री अनंत कुमार जी, विशेष महानिदेशक प्रोजेक्ट रीजन न्यू दिल्ली श्री पुष्पेंद्र सिंह चौहान जी, विशेष महानिदेशक रीजन चेन्नई श्री CK वर्मा जी, केंद्रीय लोक निर्माण विभाग के सेवानिवृत्त अधिकारीगण तथा इस सत्र में उपस्थित सभी अतिथियों का मैं हार्दिक अभिनंदन करती हूँ। अब मैं आदरणीय अपर महानिदेशक श्री DC गोयल जी से निवेदन करती हूँ कि वह महानिदेशक श्री शैलेंद्र शर्मा जी का स्वागत करें। धन्यवाद सर। केंद्रीय लोक निर्माण हेलो
कैसे हो गया मामला मनीष का? कहाँ भाग गए सारे लोग? आराम से आराम से।
केंद्रीय लोक निर्माण विभाग की पूरे देश में बृहत उपस्थिति है और इस विभाग में कठिन पर्वतीय क्षेत्रों में भी जटिल परियोजनाओं का निर्माण तथा निर्माण के बाद के चरण में अनुरक्षण करने की क्षमता है। अनेक आयामों व चुनौतियों का सामना कर CPWD आज ज्ञान एवं अनुभवों का एक विशाल संग्रह बन गया है। ऐसे ही अनुभवों को आप सभी के साथ साझा करने के लिए मैं आज की पहली प्रेजेंटेशन के लिए मंच पर आलूवालिया कंस्ट्रक्शन से श्री PK वर्मा जी को आमंत्रित करती हूँ। ये ओवरव्यू ऑन पैरामीटर्स फॉर सिलेक्शन ऑफ प्रीकास्ट टेक्नोलॉजी फॉर बिल्डिंग प्रोजेक्ट्स पर प्रस्तुति देंगे। सभी श्रोताओं से अनुरोध है कि वे अपने प्रश्न नोट कर लें। सत्र के अंत में हम सारे प्रश्न एक साथ ही लेंगे। सर
पब्लिक लगता है इस चक्कर में कि इसके बाद तो वैसे ही
Good afternoon, friends, and my old colleagues on the dais. It is मैं हिंदी में बोलूँ या इंग्लिश में बोलूँ? अच्छा, नहीं, हिंदी भी ठीक है। तो हाँ, तो मुझे ये जो सौभाग्य मुझे प्राप्त हुआ है फिर से एक बार इस फोरम में बोलने का, इसके लिए मैं शैलेंद्र शर्मा जी को थैंक यू बोलता हूँ। और आप सब लोगों को मैं चाहता हूँ कि मैंने कुछ जो अपना ज्ञान और अनुभव अर्जित किया है वो शेयर करूँ। तो मैं एक थोड़ा सा बैकग्राउंड देना चाहता हूँ इस बारे में। प्रीकास्ट टेक्नोलॉजी अब इंडिया में हम यूज़ करते हुए काफ़ी समय हो गया है और बहुत सारी टेक्नोलॉजी हमने यूरोपियन देशों से कॉपी की, कुछ इंडिया में भी डेवलप करने की कोशिश की और दूसरे कुछ देशों से हमने पूरी तरह टेक्नोलॉजी को अडॉप्ट नहीं किया जहाँ पर और अच्छे काम भी हो रहे हैं। लेकिन वो सारे सिस्टम किसी और रीज़न से उन देशों में डेवलप हुए थे और हम उनको करीब करीब उसी तरह से कॉपी कर ले रहे हैं जैसे उन्होंने अपने लिए डेवलप किया था। तो कहीं ना कहीं एक एक शॉर्टफॉल आ रही है, एक प्रॉब्लम आ रही है उस टेक्नोलॉजी को अडॉप्ट करने में, और पूरी तरह से हम उस प्रीकास्ट सिस्टम्स को उनके अडॉप्ट नहीं कर पा रहे। बहुत सारे कारण हैं। तो मैंने सोचा कि एक छोटा सा प्रेजेंटेशन मैं बनाऊं, जिसमें मैं इस प्रेजेंटेशन को वैसे मैं सिर्फ बिल्डिंग वर्क्स के लिए लिमिट कर रहा हूं, और जो अभी प्रेवलेंट सिस्टम्स अवेलेबल हैं इंडिया में, उसमें हम किस तरह से उनको बेस्ट तरीके से यूज़ कर सकते हैं, क्या टेक्नोलॉजी अवेलेबल है, उसके लिए क्या सिस्टम रिक्वायरमेंट होती है, क्या स्किल मैन पावर रिक्वायरमेंट होती है, और उस टेक्नोलॉजी को किस तरह से यूज़ किया जाता है। थोड़ा थोड़ा मैं इस बारे में बात करूँगा और उस नॉलेज को हम आगे यूज़ कर सकते हैं कि कौन सी टेक्नोलॉजी किस प्रोजेक्ट के लिए अडॉप्ट करनी चाहिए। तो मैं अपने सिस्टम प्रेजेंटेशन को बेसिकली 5 टेक्नोलॉजीज़ पे लिमिट करूँगा। एक है लार्ज पैनल एंड वॉल सिस्टम, जो हम ज़्यादातर लोग हम जानते हैं, और हम ज़्यादातर इसी टेक्नोलॉजी को इंडिया में यूज़ कर रहे हैं, जिसमें हम वॉल्स को और फ्लोर्स को कास्ट करके और असेंबल कर लेते हैं और अलग अलग तरीके से इनको स्टिचिंग मेथड से कनेक्ट कर लेते हैं। दूसरा सिस्टम है हॉलो कोर स्लैब्स का। तीसरा सिस्टम है लैटिस गर्डर, जो इंडिया में बहुत कम यूज़ हो रहा है, शायद एक आधी जगह कहीं यूज़ हुआ है। और तीसरा है प्रीकास्ट कॉलम्स एंड बीम्स। ये पहले भी इंडिया में जब शुरुआत हुई थी टेक्नोलॉजी की, तब प्रीकास्ट कॉलम्स एंड बीम्स हमने काफ़ी यूज़ किए। बहुत सारे कारणों से ये आगे नहीं बढ़ पाया, लेकिन अभी भी कहीं कहीं इसका उपयोग है। फिर पांचवा सिस्टम जो है वो स्ट्रक्चर विद कॉलम्स एंड स्लैब्स विदाउट बीम्स। ये सिस्टम रशिया में डेवलप हुआ है और इंडिया में एक ही जगह यूज़ हुआ है, जो हमने बहादुरगढ़ में एक प्रोजेक्ट बनाया था, उसमें ये यूज़ हुआ है। बहुत अच्छा सिस्टम है। तो हमारे पास प्रॉब्लम क्या होती हैं जब हम किसी भी प्रीकास्ट टेक्नोलॉजी के बारे में काम करने की सोचते हैं या कोई टेक्नोलॉजी अडॉप्ट करने की सोचते हैं कि हमें कोई सिस्टम प्रीकास्ट में बनाना है। तो अभी क्या हो रहा है आजकल, पहले प्रोजेक्ट बन जाता है, उसके बाद वो प्रीकास्ट टेक्नोलॉजीज़ के पास आता है कि इसको आप प्रीकास्ट में कन्वर्ट कर दीजिए, और वो सबसे बड़ी समस्या है, क्योंकि पहले कॉन्सेप्ट किसी और चीज़ से बनता है, वो ट्रेडिशनल या मोनोलिथिक कंस्ट्रक्शन के हिसाब से बनता है, और उसको प्रीकास्ट में कन्वर्ट करने में काफ़ी प्रॉब्लम्स आती हैं। तो पहले एक तो प्रोडक्शन की इशू हमें सोचना होता है, दूसरा हम उस मटेरियल को, जो प्रीकास्ट मटेरियल है, उसको यार्ड में रखेंगे या साइट पे रखेंगे, किस तरह से उसको स्टैकिंग करेंगे, उसका ट्रांसपोर्टेशन कैसे होगा, क्योंकि कोई एलिमेंट काफ़ी भारी होते हैं, कोई काफ़ी बड़े होते हैं साइज़ में, और रोड भी हमारी कई जगह एक्सेसिबल नहीं होती हैं जहाँ पर हम काम कर रहे हैं, या जो बड़ा प्रोजेक्ट होता है तो वहाँ एक्सेस रोड कई बार पूरी तरह नहीं बनी होती हैं, वो ट्रांसपोर्टेशन इश्यूज़ होते हैं। फिर उसकी असेंबली कैसे की जाएगी, क्योंकि असेंबली इक्विपमेंट और असेंबली करने का तरीका, ये भी एक कॉम्प्लेक्स प्रॉब्लम है जिसको हमें सोचना चाहिए बिफोर वी डिसाइड ऑन एनी प्रीकास्ट टेक्नोलॉजी। एंड फाइनली द लेगेसी वैल्यू ऑफ वॉट एवर इंफ्रास्ट्रक्चर वी आर गोइंग टू क्रिएट, चाहे हम प्रोडक्शन के लिए करें या हम असेंबली के लिए करें। मैं बीच बीच में थोड़े थोड़े एग्जाम्पल दूंगा आपको कि कहाँ पर ये प्रॉब्लम आती है लेगेसी वैल्यू की, कि बाद में हमारे पास ऑर्डर बुक नहीं होती या उतनी बड़ी मशीनरी का कोई यूज़ नहीं होता है, and that runs into some hundreds of crores sometimes that production system. तो इन सब के लिए क्या चाहिए? We should do a critical thinking, जिसमें identifying of problem, we have to analyze the things, we have to reflect on each aspect, then we have to evaluate various aspects and do some reasoning for going ahead with the particular type of technology for a particular project. तो मैं एक बेसिक ओवरव्यू देता हूँ एक प्रीकास्ट सिस्टम कैसे हम कंसीडर करना शुरू करते हैं। जैसे एक साइज़ ऑफ प्रोजेक्ट क्या होना चाहिए एक पर्टिकुलर प्रीकास्ट सिस्टम के लिए, उसकी वायबिलिटी के लिए, रिपीटिशन ऑफ मॉड्यूल्स के लिए, या उस पूरा जो हम यूनिट लगा रहे हैं उसकी वायबिलिटी के लिए। देन द हाइट ऑफ बिल्डिंग, सम प्रीकास्ट सिस्टम्स दे आर लिमिटेड टू सर्टेन हाइट ऑफ बिल्डिंग्स, उससे ऊपर वो नहीं जा सकते, या आपका जो असेंबली सिस्टम्स हैं वो उससे ऊपर नहीं जा सकते हैं, या कोई प्रीकास्ट सिस्टम ऐसा होता है जो लो राइज में अच्छा काम करता है। देन रिपीटिशन ऑफ मॉड्यूल्स, This is again very important thing because precast system, the economy of precast system depends on repetition of modules. Then timelines for completion, कितना बड़ा establishment चाहिए, कितने मोल्ड चाहिए, प्रोडक्शन कैपेसिटी क्या चाहिए, असेंबली कैपेसिटी क्या चाहिए. देन अवेलेबिलिटी ऑफ एरिया फॉर प्रोडक्शन, क्या आपके पास साइट में प्रोडक्शन का एरिया है अवेलेबल, या आपको सेंट्रलाइज प्रोडक्शन करना है और वहाँ से ट्रांसपोर्ट करना है. देन देर आर स्पेशल रिक्वायरमेंट्स ऑफ फिनिशेस फीचर्स, जैसे कई बार हम डिसाइड करते हैं कि हम टॉयलेट और किचन का एक 3D मॉड्यूल बना लेंगे, या हम लिफ्ट के लिए एक 3D मॉड्यूल बना लेंगे, स्टेयर केसेस को हम प्रीकास्ट कर लेंगे, या वॉल्स हैं, फसाड है, फेशिया है, इनको हम प्रीकास्ट कर लेंगे. तो इस तरह के जो स्पेशल फिनिशेस की रिक्वायरमेंट है उस प्रोजेक्ट की, उसको कैसे कैटर किया जाए. देन द ट्रांसपोर्टेशन लॉजिस्टिक्स, जो मैंने पहले भी बताया कि वेदर इट इज़ फीजिबल टू ट्रांसपोर्ट दैट साइज एंड द लेंथ एंड द क्वांटिटी ऑफ मटेरियल, बिकॉज इफ़ यू आर नॉट एबल टू फीड द साइट तो आपका साइट स्लो हो जाएगा, प्रोडक्शन एरिया में स्टैकिंग बढ़ने लग जाएगी. अगर आप ज़्यादा ओवर फीडिंग कर देंगे तो साइट पर जगह नहीं बचेगी काम करने के लिए. इस तरह की रिक्वायरमेंट्स को हमको वर्कआउट करना होता है. देन कैपिटल इन्वेस्टमेंट इन डेवलपिंग प्रोडक्ट्स, प्रोडक्शन एंड असेंबली फैसिलिटी एंड इट्स लेगेसी वैल्यू. मार्केट सेंटिमेंट्स, दीज आर ऑल्सो वेरी इंपॉर्टेंट. ऑफकोर्स गवर्नमेंट में इतना नहीं होता है, लेकिन प्राइवेट सेक्टर में ये देखना पड़ता है कि आपकी मार्केटेबिलिटी क्या है. कई बार लोग एक कॉन्क्रीट केज में नहीं रहना चाहते, लेकिन हम बहुत सारे प्रीकास्ट सिस्टम्स में उनको एक कॉन्क्रीट केज देते हैं जो बड़ा रिजिड फॉर्म होता है. जैसे हम लार्ज पैनल वॉल सिस्टम की बात करें तो लगभग हर वॉल उसकी एक स्ट्रक्चरल मेंबर होती है एंड इट इज स्ट्रक्चरली एक्टिव. तो उस घर में कोई रीमॉडलिंग करना हो, किसी को फ्यूचर में कोई दरवाज़ा निकालना हो, खिड़की निकालना हो, या किसी को एक कील ही ठोकना हो, छोटे जैसे EWS हाउसेस हैं, उनको अपने घरों में काफ़ी कुछ करना होता है, वो सब पॉसिबिलिटीज़ उसमें काफ़ी मुश्किल हो जाती हैं. तो ये एक मार्केट सेंटीमेंट होता है जो प्राइवेट एंटरप्रेन्योर्स को डिसाइड करने में एक बड़ा फैक्टर होता है कि हमें किस तरह की टेक्नोलॉजी यूज़ करना चाहिए ताकि उसकी मार्केटेबिलिटी भी अच्छी हो. देन वी कम टू ए सिलेक्शन ऑफ प्रोडक्शन सिस्टम. तो प्रोडक्शन सिस्टम एक प्रकार से जब हम प्रीकास्ट टेक्नोलॉजी डिसाइड करते हैं किसी प्रोजेक्ट के लिए, और उसमें प्रोडक्शन सिस्टम काफ़ी कुछ डिसाइड हो जाता है, लेकिन प्रोडक्शन सिस्टम भी अब हम ब्रॉडली अगर बात करें तो दो तरह के हो सकते हैं. एक सेंट्रलाइज हो सकता है और एक ऑन साइट हो सकता है. दोनों की अपनी अपनी रिक्वायरमेंट हैं. जैसे सेंट्रलाइज सिस्टम है उसमें मैन्युफैक्चरिंग रिक्वायरमेंट आपकी फास्ट हो सकती है, इट कैन बी मोर ऑटोमेटेड. तो ये वॉल्यूम ऑफ प्रोडक्शन इस पे डिपेंड करता है. ट्रांसपोर्टेशन लॉजिस्टिक्स इसमें इंपॉर्टेंट हो जाती हैं कि आपने सेंट्रलाइज प्रोडक्शन बना तो लिया, लेकिन साइट पे ट्रांसपोर्टेशन लॉजिस्टिक आप मैनेज नहीं कर पा रहे, क्योंकि या तो एक्सेसिबिलिटी नहीं है या डिस्टेंस इतना ज़्यादा है कि आपको ट्रांसपोर्ट करने के लिए बहुत बड़ा ट्रांसपोर्टेशन सिस्टम चाहिए और आप डिमांड मीट नहीं कर पा रहे. इसकी फ्यूचर डिमांड क्या है जो सेंट्रलाइज सिस्टम है, वेदर यू विल बी हैविंग फ्यूचर ऑर्डर बुक्स इन एंड अराउंड दैट एरिया, और बजट आपका क्या है, क्योंकि ये काफ़ी महंगा होता है एंड इट वर्क्स ऑन लॉट ऑफ ऑटोमेशंस. तो इसके लिए इसकी कॉस्ट भी देखनी होती है. जो ऑन साइट है उसमें हमें देखना होता है कि वेदर वी हैव सफिशिएंट स्पेस अवेलेबल टू पुट दैट प्रीकास्ट सिस्टम, या हमने प्रीकास्ट सिस्टम ही ऐसा डिसाइड किया जो साइट पर बन सके. मैन्युफैक्चरिंग रिक्वायरमेंट्स क्या होती हैं, ऑटोमेशन रिक्वायरमेंट क्या है. साइट पर जो आप सिस्टम लगाते हैं इट कैन बी ऑटोमेटेड, सेमी ऑटोमेटेड और 100% मैनुअल, उस तरह से भी बना सकते हैं. देन रीलोकेटिंग फीजिबिलिटी, जो हमने सिस्टम लगाया उसकी रीलोकेशन कॉस्ट क्या है एंड फ्यूचर डिमांड उसकी उस तरह के सिस्टम की क्या आने वाली है, दिस डिसाइड्स. और इसके पहले कि मैं आगे बढ़ूं, मैं कुछ और ये भी कहना चाहता हूं कि जो भी हम प्रीकास्ट सिस्टम कभी कोई सोचे भी हम कोई प्रोजेक्ट करना चाहें प्रीकास्ट सिस्टम से, तो हमें आर्किटेक्ट्स को भी शुरू से ही इन्वॉल्व करना चाहिए कि हम किस तरह का सिस्टम अडॉप्ट करने जा रहे हैं, उसमें क्या उसकी प्रॉब्लम्स हैं उस सिस्टम को अडॉप्ट करने के लिए, उस सिस्टम के क्या डिसिप्लिन हैं, सो दैट द आर्किटेक्ट्स कैन डू देयर डिज़ाइन ऑन द बेसिस ऑफ दोज डिसिप्लिन्स. अगर आर्किटेक्ट ने अपनी एक डिज़ाइन कर ली एंड देन इफ़ हम उसको बोलें कि इसको आप चेंज कर दीजिए, या ये रूम बड़ा कर दीजिए, छोटा कर दीजिए, या स्पान चेंज कर दीजिए, उनके लिए बहुत डिफ़िकल्ट होता है उस समय. जब नक्शे सारे पास हो चुके हैं और आपकी डिज़ाइन फ्रीज हो चुकी है, प्रोजेक्ट पूरा अप्रूव हो चुका है, और उस स्टेज में अगर हम सोचें कि अब इस टेक्नोलॉजी को बदल के हम ये टेक्नोलॉजी कर दें या इसको हम अडॉप्ट कर लें, वो बड़ा मुश्किल काम होता है। तो मैं एक एक करके आपको अलग अलग सिस्टम्स पे ले जाता हूँ। जैसे यूजिंग लार्ज वॉल पैनल्स एंड स्लैब्स, इसमें हम वॉल्स के और स्लैब्स के पैनल्स को अलग अलग टाइप के मोल्ड में कास्ट करते हैं, एंड देन वी गेट देम असेंबल्ड एट साइट यूजिंग डॉवल सिस्टम्स, समटाइम्स नट्स एंड बोल्ट्स ऑल्सो, जहाँ पे बिल्कुल सिस्मिसिटी नहीं है, लो राइज मकान है, लोग इनको नट बोल्ट से भी असेंबल कर देते हैं। And then we can form different type of vertical and horizontal joints which are of very high quality. इसी में कुछ सैंडविच पैनल की तरह भी यूज़ होते हैं, जिसमें आप प्री इंसर्टेड इंसुलेशन डाल देते हैं, इज़ फॉर वेरी गुड थर्मल कैपेसिटीज़। एंड इसका एडवांटेज ये भी होता है कि हमें दोनों साइड फिनिश्ड सरफेस मिल जाता है मोल्ड का, और कई बार हम दो लैटिस गर्डर को जोड़कर एक सैंडविच पैनल बना लेते हैं। We can also use pre-finished walls with brick cladding or any type of other cladding done. Then this is again a precast wall and slab construction. ये पिक्चर मैंने इसलिए लगाई है कि जब आप इसमें आप काम करते हैं तो देखिए आपको कई तरह के प्रॉब्लम आते हैं। जैसे आपको वॉल को रोकने के लिए, उसका अलाइनमेंट करने के लिए, या उसकी वर्टिकलिटी को मेंटेन करने के लिए इस तरह से आपको पुश पुल प्रॉप्स के साथ इसको रोकना होता है टिल इट इज़ ग्राउटेड एंड अचीव्स स्ट्रेंथ। ये पर्टिकुलर सिस्टम जो है ये हाइब्रिड सिस्टम है, इसमें वॉल को कॉलम के साथ भी अटैच किया गया है। वॉल जॉइंट ना होके इट इज़ गेटिंग कनेक्टेड थ्रू ए हाइब्रिड मोनोलिथिक कॉलम सिस्टम। ये कुछ प्री फिनिश्ड फ्लोर्स एंड वॉल्स हैं, जिसमें पहले से आप देखिए टाइल लगी हुई हैं, प्लम्बिंग इसमें हुई है, स्टेयर केस भी सारी प्री फिनिश्ड हैं, और सारा का सारा जो स्टेयर केस में एंटी स्किड टेक्सचर है वो कास्टिंग के साथ ही इसमें डाल दिया गया है। लेकिन चूंकि फ्लोर ऑलरेडी लगा हुआ है, तो अगर हम हाउ वी गो बैक या तो अगर हम इस तरह का असेंबली सिस्टम लगाते हैं, जिसमें कि हमें यहाँ पर एक फासना लगाना पड़ेगा, फ्लोर में भी फासना लगाना पड़ेगा, तो अगर हम प्री फिनिश सिस्टम में जाते हैं और हमें अगर असेंबली सिस्टम लगाना है, तो हमने एक इस तरह का असेंबली सिस्टम डिज़ाइन किया जो फ्लोर और वॉल को डैमेज नहीं करता। एंड दिस सिस्टम हैज़ प्री इंसर्ट्स जो लिफ्टिंग के भी काम करते हैं, वहाँ पर लिफ्टिंग का हुक भी असेंबल हो जाता है, और ये सिस्टम भी असेंबल हो जाता है जो प्री फिनिशेस को, आपकी टाइल्स वगैरह को डैमेज नहीं करता। देन this is the production system. You can produce these panels on flat surfaces. जब हम वॉल बनाते हैं तो हम टिल्टिंग टेबल्स यूज़ करते हैं, क्योंकि वॉल को हम हॉरिजॉन्टली लिफ्ट नहीं करना चाहते, उसके स्ट्रेंथ उसमें अननेसेसरली स्टील और रेनफोर्समेंट प्रोवाइड करना पड़ेगा फॉर द स्ट्रेसेस विच आर कमिंग इन हॉरिजॉन्टल लिफ्टिंग। तो इन टिल्टिंग टेबल्स को वर्टिकल करके, वॉल को वर्टिकली लिफ्ट करके वर्टिकली स्टैक किया जाता है, वर्टिकली ट्रांसपोर्ट किया जाता है और वर्टिकली असेंबल कर दिया जाता है। Some pictures of a production yard. Then these are called battery molds. एक बैटरी में, इसमें तो कम है, वैसे 12 बैटरीज होती हैं, एंड these batteries can be of 6 meter by 3 meters or even 12 meters by 3 meters. These can be rested on floors, or they can also be on the they can also hung from top so that the floor is clean. इन बैटरी मोल्ड्स में जनरलाइज प्रोडक्शन वॉल्स का, फ्लोर का भी इसमें हो सकता है, बट मोस्टली इट इज़ यूज फॉर वॉल प्रोडक्शन। ज़्यादातर इसमें हम मैग्नेटिक फॉर्म्स यूज़ करते हैं, सो दैट दे आर अटैच टू दिस बैटरीज, और बैटरी क्लोज करके फिर इसमें कॉन्क्रीटिंग कर दी जाती है। So now we talk of advantages and issues to be considered in this kind of system. The first is a faster completion. Yes, certainly it gives you a very fast completion. और दूसरा है structure with walls and floors getting completed simultaneously. So हम अलग से brick work, block work या wet work नहीं करना पड़ता, प्लास्टर की ज़रूरत नहीं होती। Plumbing and electrical conduits ये बहुत आसानी से इसमें प्री इंसर्ट किए जा सकते हैं, और जहाँ पर कनेक्शन आ रहे हैं इसके टिपिकल कनेक्शंस मिलते हैं और डेवलप किए हुए हैं, जो इलेक्ट्रिकल जॉइंट्स बना देते हैं या प्लम्बिंग जॉइंट्स बना देते हैं. देन वी कैन हैव टेक्सचर्ड एंड प्री फिनिश वॉल्स. दोनों साइड फिनिश इंसुलेटेड सरफेस वॉल्स मिल सकती हैं. एंड देर इज़ ए वेरी वेरी लो वेट वर्क एट साइट. साइट पर वेट वर्क बहुत कम हो जाता है. प्रॉब्लम्स इसमें आती हैं कि एलिमेंट्स आर रिक्वायर्ड टू बी प्रोड्यूस्ड मोस्टली इन सेंट्रलाइज फैक्ट्री एंड ट्रांसपोर्टेड. क्योंकि एक बिल्डिंग को जब हम ओपन करते हैं तो जितना उसका फ्लोर एरिया होता है करीब करीब उससे 5 गुना उसकी प्रोडक्शन एरिया हो जाता है 4 वॉल और मिला के. तो हमें प्रोडक्शन एरिया बहुत चाहिए होता है. अगर हमें बहुत स्पीड से प्रोजेक्ट करना है तो हमें नंबर ऑफ मोल्ड्स भी बढ़ाने पड़ते हैं. सो इसलिए मोस्टली ये सेंट्रलाइज्ड फैक्ट्रीज में यूज़ किया जाता है जहाँ पर ऑटोमेशन भी होता है, स्टीम क्यूरिंग सिस्टम होता है, स्टैकर क्यूरिंग सिस्टम होता है, जहाँ हम इसको तेज़ी से प्रोड्यूस कर सकें. ट्रांसपोर्टेशन लॉजिस्टिक इज़ कॉस्टली and difficult to maintain. High capital cost of production establishment, yes, it is very high. High volume of projects are required to have optimized use of production facility. Availability of sustainable order book is also very important. क्योंकि इतना बड़ा सिस्टम लगा लिया और ऑर्डर बुक नहीं है तो सस्टेन करना मुश्किल है. जॉइंट्स एंड वाटर टाइटनेस, ये एक स्पेशल अटेंशन इसमें चाहिए होता है. बिकॉज यू सी जॉइंट्स इन दिस सिस्टम and they are to be made watertight. So you can use chemical barriers, you can use physical barriers, you can use combination of them. Systems are available. Then production gets rigid form. It provides very rigid form to the building. And also restraining a progressive failure is very difficult in this kind of design. Because if one element goes, the building should not come down like pack of cards. तो इसलिए इसकी डिज़ाइन इस मामले में थोड़ी सी डिफ़िकल्ट होती है और डिज़ाइनर को इसमें स्पेशल अटेंशन देना होता है. दिस डेफिनेटली रिक्वायर्स स्किल्ड मैन पावर सेट बिकॉज द असेंबली ऑल्सो इज स्किल्ड एंड द प्रोडक्शन इज ऑल्सो स्किल्ड. नाउ लेटिस गर्डर, दे आर मोर और लेस सिमिलर, डिफरेंट काइंड ऑफ यूज. द लेटिस गर्डर इज लाइक हाफ स्लैब्स. दे रिड्यूस योर shuttering and centering systems for slabs, mostly used for slabs. Some people use it for wall also. So they can be produced on long beds or on carousel systems like this, which are automatic carousel systems. These are some lattice girders. The advantage is you can put all the services and do second layer of slab on this. So when the services are very high, particularly in European countries, where you have to do floor heating also, this kind of system works really well. You can see the lattice girder. The problem is that they come in lesser width, and you see the joints below. So you can see the construction here. The lattice girders, sometimes they are used as a double lattice girder for wall and floor slab also. And this, you can just pour concrete into this and this becomes solid. Very rarely used. So it is easy in laying of embedded services. The plaster is not required. The plumbing and electrical conduits can be pre-inserted very easily. You can have both side finishes, and it is fast in production. But it has very limited use. They are required to be produced in a centralized factory. It cannot be produced at site. The transportation logistic is costly, high capital cost of production system, very limited use. Joints and water tightness is very difficult to attain in this kind of system. It requires high skill manpower and specialized machinery, and there is large amount of wet work in this system. Now hollow core slabs, everybody must have heard of this. So hollow core slabs are actually pre-tensioned, pre-stressed slabs, and they have their own advantages. Their production capacity can be 200 square meter to 2000 square meter. It requires a lesser space, and the length of bed can be 70 meter to 200 meter. So you do a long line pre-stressing in this, pre-tensioning, and then you can cut this slab to any size after it is pre-tensioned and pre-stressed. So the width can vary from 0.5 meter to 1.2 meter. There is a restriction in the width here. The walls and slabs are connected using various connection methods. Sometimes structural screed is used, and sometimes you use the dowel bars from the wall bent into this slab and grouted. So these are some long beds you can see for hollow core slabs. This is an extrusion machine. And these are the constructions, some type of construction. You can see the, look at this hollow core. This is a steel beam, and the hollow core slabs are being laid directly over it. And these are all hollow core slabs. Very large spans, up to 12 meters are possible in this. They are light in weight. They put less load on the foundation, and they are very strong. So the advantage is they are light, large span possible. They provides unsupported working platform immediately after placing. They are easy to transport, and also they can be cut into any size, mainly used for buildings with larger spans and with heavier loadings, such as office buildings, parkings, hospitals, schools, mostly because they are aesthetically not very good, but where you are providing false ceiling and screed over it, so you don't see hollow core anymore. And the issues are elements need to be produced in a centralized factory. That is a must. Transportation logistic is costly. Limited structural use. Joints and water tightness require special attention. They require a structural screed for making connections, and the wet work is higher than the normal system here. Then there are prevalent systems with using precast columns and beams. So everybody is, I think, well versed with this. The columns are casted with brackets to hold the beams, and the beams are placed on these brackets. They can be connected through nuts and bolt system. They can be connected through grouts. They can be connected through dowel walls, through bars. Various type of systems are available for connection, depending upon the forces coming on these joints and the type of the seismic zone or horizontal forces it is experiencing. So they can be used in combination with hollow core slabs very easily and nicely. So advantages are very large spans are possible, fast and economical construction for industrial buildings, can be provided with different cladding systems. They can take any kind of cladding system. Actually, most of the precast systems can adapt to any kind of cladding system. Then aesthetically, it is to be carefully considered. There are large number of joints in this system, limited to high-rise. There is very limited use. Actually, they cannot be used in high-rise buildings. Very limited number of stories can be developed with this, and skilled manpower is required for this kind of system. Now I am taking you to the fifth system, which is precast columns and slabs without beams. This system was developed around 60s in Russia, and it has progressed a lot after development. So this is a very simple system. Number one, it requires only 3 types of slabs and a mold for column. So with just 4 molds you can construct the building. And if you want production to be higher capacity or you want to increase the production, you just increase these molds in that proportion of requirement. So it is a very simple system, very efficient. I'm just taking you to a project where we have used this system. This was the site of around 10.3 acres, and 13 towers to be built were to be built. The configuration was still plus 14 floors, and this small area was available for production. You can see this corner here. So this was the production area we developed. It was 100 meter by 25 meters only, and we used very little automation in this. We have provided only 2 gantries of 10 meter each, and we have placed a batching plant over here for the casting and the concrete purpose. This small system could produce 1 floor per day of 1 tower. So you can see this system. These are the molds here, and the material was stacked around that. These are the column molds and slab molds. And this is the production worker site. The best advantage of any precast system, and including this, is you don't have to work at height. your workers are working at your waist level. They don't have to bend down. Don't have to pull themselves up. They are working at waist level. So you can just it's running. The assembly इधर ही करना पड़ेगा. Okay, going very fast. So I'm just showing you some videos of the activities at site. You can see the compacted. The concrete is self-compacting type, and the staircase reinforcement is being tied. Just move forward. The advantage of the system is this can work up to 25 floors, and this is as efficient in low rise as it is efficient in high rise buildings. The columns can be erected for 4 floors in one go. That is the advantage here, that you insert the columns in the foundations, and then you insert the slab from the top and make connection of this. So you can just see the insertion of the slab, how it is inserted. So there are 3 types of slabs. One is the column slab. The second one is between 2 columns, and the third one which comes at the center. So you can see the configuration here, the column slab, the central slab, and the middle slab. You can see here the column slab, the slab between 2 columns, and the middle slab. Each slab is 3 meter by 3 meter. That's an standard mold, standard size. So this system develops its own modularity. It is modular in itself. So you don't need units to be very, very modular. You can develop modularity within the system itself, and it becomes economical. The factory is highly flexible. You can increase or decrease size of factory just by adding molds or reducing molds. So it takes around 5 to 6 minutes to install any column or slab. So it takes about 4 to 5 hours to make one floor, and we could do 2 towers of 14 floors each in just 2.5 months. You can see these buildings. Okay, I have a different slide for that. See, these slabs, they are having overlapping loops. हाँ, इसमें overlapping loops हैं, उसके बीच में से बाहर जाता है, and then you grout it, and the system becomes kind of a paramedical system. So when it tries to rotate, couple is formed. So वो उसकी जो moment compatibility बहुत अच्छी हो जाती है. I can explain more in this system, पर वो मेरे लैपटॉप में है दूसरी slides. The advantage is you can place walls anywhere in this, and you can remodel your building at any time, because the walls are not structural members. Okay, this conclusion. So I'm just running fast now. I'm running out of time, sorry. So this facilitates very high speed construction, and there are advantages. The limitations, I will just talk the limitations. The limitations are spans. It cannot take more than 6 meter by 6 meter span, and the story height is limited to 25 floors. But maximum story height is 6 meters. So that is the limitation of this system. And now I will just quickly take you to some 3D elements which are requirement of this, like lifts. So these are the lifts, and they are to be inserted from top, but they give you a very advantage of faster construction. The stairs, these are the molds for stairs. These are the reinforcement for stairs. Final products, my picture is also there. And there are some stairs with finishes, so that anti-skid finish can be obtained. no further finishing is required. And I'm just showing you this fascia elements for South Asian University, Delhi. The entire fascia in this building is precast. So we have developed precast molds for this. Even those benches here were precast. And this is after completion. This is Danish Embassy in Chanakyapuri. These fins are 4 meter high. This is the boundary wall for Benedict University. So, just for concluding, I want to sum up my presentation saying that when we decide on any precast system, we should decide when, before we draw any line on the drawing board, before we start planning for the structure and also the design of the building, considering all these aspects so that the precast system, whatever we are adopting, is useful and economical and can be reproduced in other buildings also. Thank you very much.
धन्यवाद सर, बहुत ही ज्ञानवर्धक प्रस्तुति। प्रीकास्ट सिस्टम्स के प्रैक्टिकल एस्पेक्ट्स को आपने बहुत सरलता से समझाया। अगली प्रेजेंटेशन के लिए एलएनटी से श्री अमित बर्डे जी को आमंत्रित करती हूँ। ये प्रीकास्ट कंक्रीट टेक्नोलॉजी फॉर रैपिड कंस्ट्रक्शन इन रेजिडेंशियल एंड कमर्शियल कंस्ट्रक्शन पर प्रस्तुति देंगे।
Very good afternoon everybody. I am from Mumbai. मुझे हिंदी आती है पर दिल्ली में नहीं आती है। दिल्ली का शुद्ध हिंदी अगर मैं यहाँ चालू करूँगा तो आप मुझे जाने को बोलेंगे. So I'll just stay with English. To all the dignitaries on the dais, it's been an honor and a pleasure to be here in CPWD. Even the morning function when I went through all the kind of volumes and projects you are doing. We usually at L&T take pride in innovation, and the degree of innovation and variety of work is going here is just absolutely fascinating. So really a pleasure to be here. What I'm going to do today is what L&T has been doing in precast for last 10-12 years. And when I say 10-12 years, precast in the commercial and residential building sector. We have been doing precast for long, I think more than 30-40 years. In infrastructure, precast has become a norm. But somewhere in 2010, the management felt that the building construction industry, whatever that is going through or the conventional ways that we are building, that's not going to be enough. And this is where the precast initiative was born at L&T in 2011 time frame. And this is pretty much the summary of what we have been doing since then. So these are some of the key projects what you see on the screen, mainly in the residential. I'm going to focus today on the residential because of the mass housing needs and where CPWD focus is too. But at the same time, some of the commercial projects, very niche key projects we'll be discussing. There is a lot of content and we don't have enough time. So what I will be going is I'll be rushing through it. But of course, I'm here through the rest of the day. So if there is anything of your particular interest, we can discuss in detail. So L&T, usually we are not very well known in the market for doing residential work, but we do a lot of it. Actually, large and tall, that's what we are looked at. So these are some of the high-rise projects in the conventional construction that we have been doing. Of course, in the commercial sectors also and the public spaces, we do a lot of landmark projects that is well known. But when it comes to precast, our Shri Narendra Modi Stadium at Motera, this was done in total precast. We are now building the high-speed railway project that is being done in total precast. What you see in the picture is a 1,000-ton girder, about 40 meter long. And the equipment that is carrying it is also made in India, and we are really, really very proud of it. Everything, right from the design to construction, that straddle carrier was made in India. So what do we do in precast? So largely what I'm going to do, like I said, Why precast, why in residential, then we'll go through the case studies. While we go through the case studies, I'm going to explain how we have adopted that. At the end, I'm going to talk about one of the largest projects that we have taken over in mass housing sector in Sidco Navi Mumbai, over 5,000 crore value, and what we are doing in precast in that, and then we'll conclude. So we've been doing construction for long, like I said, 30, 40 years. Conventional was the way to do it. In the 90s, we tried the aluminum or the tunnel formwork system. In the 2000s, we did the aluminum formwork. Aluminum formwork, of course, is by far the most popular system. And 95% of our in-house projects, we use aluminum formwork. And then 2010, we moved to precast. It's pretty much the next step of aluminum formwork. Exact same system, same design philosophy, except we are making that building in parts, producing it at the factory, and then assembling at site. So just a little one, I think some of these numbers, especially for the dais, they will be small, but I just wanted to put why precast. So if you start comparing the conventional system versus precast on a same project, so this is a project in Mumbai, what I discussed, and we have one plot going on in conventional and other plot going on in precast, and we tracked the performance at site, some of it through COVID, that how much time really we are using to build this system, and the slab cycle is the common norm. And if you see the first 25 slabs where the CIP was really faster compared to even precast, and if you start seeing the numbers, you will see that conventional is building much faster. But what you have to look at is at what resources, right? We keep talking about at what cost we are building. And in conventional, it's aluminum formwork, it's number of sets. So this conventional had about 22 sets. In the same time frame, I'm building precast plot using only 5 cranes, and my crane is my key resource there now. So what we have to look at it is how many slabs I'm building per key resource, per set or per crane. And if you start seeing that, it's very obvious in the graph itself that we are at least having a productivity of 30 to 40% more. But it's just not productivity. If you see the sustenance, right? If you see this graph, the conventional, which is orange here, it kind of took a long time, the initial cycle time, initial learning curve. Then it got better, then COVID hit and it got worse. The graph kind of picks up. But in precast, once you pick up the initial, through COVID also, we have been doing 8 to 10 slabs, 8 to 10 days per slab. So that is the point that we would really like to drive. And how it translates in terms of the actual productivity. If you see the aluminum formwork, which is the conventional system, I'm looking at per cubic meter about 5.5 man hours, right? Whatever the amount of resources we need to deploy. If I use the conventional system, conventional precast system, which is, I think, like Vermaji was saying, that all manual, nothing fancy, basic factory, that 5.5 goes to 3.5. Right there, about 30-35% reduction. Per cubic meter, I'm using 3.5 people. If I go even semi-automatic, which is not even the state of the art, maybe somewhere in between, that 5.5 becomes 2.5 man hours per cubic meter. This is where this is why we are chasing technologies, is to improve that productivity. What the pinch as a contractor, what we feel day in, day out, is that lack of availability of the skilled manpower. And what the whole idea is to reduce that manpower requirement. So not just these numbers, 5.5, 3.5, 2.5, if you split those numbers and start looking at it even more closely, what we are mainly looking at is reducing the activities at site. That is what my pain point is, that site quality control or the site activities. So if you see in the precast, almost 70% of the activities are done at factory. I am doing very little at actually site, and our management is saying, why 30% at site? You make that to 5%, you make it to 0. Move everything to factory, and that has been the focus where we think we will go forward. Right? So quickly going through it, we discussed about this. But what we are looking, again, this technology is the projects like this, right? This is, of course, in conventional system, what we were doing in AP housing. But that focus of the technology is for these volumes. If you say 1 building, 2 building, it may not make sense to put the precast factories. Like I think we were discussing in the morning, there are a lot of capital expenditure is there. But projects like this, where we are building 1 lakh houses, this is where the technology will come into picture. And are we the first one to do it? No, you look at our neighbors. You look at Singapore, you look at China. Everybody, developed nation, have gone through this process maybe 20 years ago, 25 years ago. What is different is all these people have taken 20, 25 years to develop. What we are looking at is making this happen in a time span of 7 to 10 years. And if you look at overall in India itself, we are doing the latest and greatest, right, in transportation infrastructure. You take a case of Mumbai, and right now, as of today, we are having metro work is going on. We are having Trans-Harbour Link road going on. We are having coastal road that is going on. New Mumbai airport is about to commence. And all these projects are being built with the latest and greatest. But somehow that residential housing sector is lagging, and that's where our focus would be. And we talked about our neighbors, and the only answer that usually comes, if you look at the history, forget India, maybe we have to look at how others did. And invariably the answer comes in terms of technology. The technology is going to be the enabler. The automation and now digitization. Those are the two new mantras that we see how the technology will evolve in next 10 years, right? I think in the morning, Honorable Minister Puri ji was saying that about 700 million square meter of work pan-India every year. That's a huge number. How that will come is through reducing the overall life cycle cost of the system. Now, if you heard Mr. Joshi in the morning mention, one of his biggest concern is the maintenance, right? And why we have taken this call of doing aluminum formwork buildings or precast buildings in RC concrete is to reduce that maintenance significantly, right? Why we are pouring or using M30 and above grade concrete and not block wall and plaster? Because we don't want these issues. Your end user faces these issues day in, day out. The plaster was never meant to be a durable material. Right? It's an efficient material in terms of finishing. It doesn't stay there. It cracks, it absorbs water, spalls, chips, paint fades. In these concrete buildings without even, I wouldn't say zero maintenance, but with a nominal maintenance, say 7 years, 8 years, 10 years, the paint does not fade. It stays as is. And this is one example. This is our own building. But the lower level, which is the first level, that was done in block work and plaster. The top level, the upper portion is precast. And 8 years down the line, you see the plaster wall has faded, needed maintenance. This has gone through actually 2 cycles of maintenance. But the precast walls are sitting there 8 years straight, not even painted again. And that's what we are looking at. Why we need low maintenance buildings is using these technology enablers. So this is that same building, ground plus 23-story tall. This was one of our first projects that we did in Mumbai. 7 buildings total, about 2,000 units, 1.2 million square foot. And whatever that you see in the picture was done in total precast system. Then we took up this next job in Bangalore, which is for a private developer. But again, large scale, about 6.6 million square feet, 5,000 houses. One building at that time was done in 3 months flat. This was in 2015 time frame. Each building has 8 flats per floor, and that was the strength of the technology what we were looking at. But besides strength, what we are mainly looking at is your end user should not feel anything different is being handed over because we are adopting technology. So if you see these pictures, the focus has always been how we can give the same what he is expecting in terms of the elevation features, the sunshades, the chhajjas, the balconies. You don't see the joints, you walk inside the flat, this is going to make and feel like an exactly same building that you are used to seeing it. That has been the focus. Same thing, we have been adopting precast. If you see, this is the facade building. So we used only the facade which has the wavy pattern, which would have been very difficult to do it in conventional systems. So facade was adopted. So the idea is now never been that force technology. What we are trying to do is wherever the site needs are there, you adopt the technology for the benefit. Right, commercial buildings, this beams, columns, and hollow core system is a very popular system. We have done a couple of jobs using that so that you can build quicker. Facade system in a commercial building, if you see, these are cantilevered offsets, so it's very difficult to do plaster and block wall there. So those elements were picked up and built in precast. This, if you see, is a building in Navi Mumbai for the IKEA warehouse. What you see in the picture is a hollow core slab, 400 millimeter thick, 16 meter span, 750 kg per square meter warehouse load. The longest span with the heaviest load in India to date. But quickly done, no supporting formwork. All 16 meter span on its own took the screed and was finished at about 50% productivity. This is one little building that you see, a very classic building, but what's different is the foundation level was only 1.5 meter below. So what we did was even the plinth was constructed using precast. So all site work was only the raft, and directly on top of the raft, the plinth panels were placed and the building was erected. Same, this is a substation building in Vizag refinery, right? 15,000 crore job, 35 crore building. But building works as a heart of that entire 15,000 crore establishment. So faster you build it, better it is they can work it out. So that was selected in precast. This is a facade system, right? The architect kind of envisioned the C-shaped wall, so they wanted, originally started with blockwork and plaster. That we converted into the panels and built quickly. This is one thing that we are trying now new in commercial buildings, facade system. So everywhere we are doing this facade using blockwork and plaster. But like I said, the maintenance issues and all, this building was a steel building. So what we did is, if you see in the picture, a little panel about 4 meter tall and 2.3 meter wide was welded to the steel structure. So what usually take, even for precast panel, it takes me about 3-4 hours to install, grout, align and all. This was attached to the building in about 35 minutes, right? I have that video one very quickly, but we can run through. So this is where we are saying ultra rapid construction, right? Where 3-4 hours also is not enough anymore. You want to run quickly and make it work. So it's a very small, maybe 20-25 second clip. But what we are looking at that, so wherever possible, because I have the steel structure, I can easily weld it. So we adopted that. I can't usually do that in an RC structure because there are complicated connections, there are design codes. The panel comes ready from the All right. So I think we have gone through that. Right. So this is something we actually did for next was bathroom and toilet. So now again the productivity improvement, where I can save time, where I can take the activity off-site, right? If you see a typical residential flat, tiling finishing is not a big deal. Painting is not a big deal. Where we spend most of the time is the toilet waterproofing, toilet tiling and kitchen tiling. So we thought, okay, why not take that finishing off-site? So we took up the toilet and bath unit. So what you see in the picture is about a 2.2 meter by 1.5 meter toilet for a 25-story building. So we said we'll just build the toilet in the factory, including all finishing. What you see in the picture, everything is done at factory. Plumbing, waterproofing, entire 17 days of waterproofing cycle was done at factory itself, nothing at site. Finished entire toilet pod was kept at the floor and then the next floor was cast. That entire unit was not touched until the building was done. When they finished the building, we came and only replaced the main door. Inside finishing was already there, including your wash basins, marbles, sanitary fixing. Outside pipes were also treated at the factory, only connections were done in the shaft, and we finished this. Right, this factory itself, we set it up at the site, so we didn't want to do even the transportation there. What you see the top corner, the crane access was directly given there. The pod set there, ready pod was directly lifted by the same tower crane and placed into the factory. What you see the molds, again, they're all in-house molds. Usually we tend to go outside and design, but we focus on making it indigenous as much as possible. So that's a full 3-meter tall mold. What you see my son in the picture is not child labor. I took him there on a Sunday. And he still talks about it. He was so fascinated that you're finishing bathrooms. So the next thing was, why are you not finishing the houses itself? And I told him that's probably coming. But that younger generation is thinking, right? He's still literally talking about it, that I've seen the pre-finished bathroom. If they can accept it, why not us? This is where we have to take that next step and start accepting where the modern technology is coming. So if you think about that, this actually snapshot, I think, if not anything, I would like to drive this. If you guys can take this home, where do we think technology is going to go? Is there going to be a single technology that will emerge out of in next 10 years? And we feel that's not going to happen. You are going to see something hybrid. So that's the left side of it, hybrid technology. You are going to see something that is pre-finished. And those two things are going to drive probably the next 10 years entire spectrum of the industry. If you start low rise, if you see at the bottom, maybe G+4 to G+5 range. We are currently doing aluminum formwork, very comfortable with it. We are exploring 3D printing. Our printer is now, actually it has come, is being assembled in Chennai, where we will be building about G+2, G+3 story houses. So that 3D printing is coming. On its own, no, it will be some monolithic, some 3D printing. If you look at the middle sector, which are G+10 to G+15 story. Again, we are doing aluminum formwork, we are doing precast, we are very comfortable with it. Where it will go, the PPVC, where we are looking at pre-finished. Everything is done at factory. Tiling, plumbing, everything, and then taken at site. High-rise sector, 25 and maybe 30, 40 stories building. We are doing aluminum formwork now. We will be doing probably hybrid sector there, where the core is still done aluminum formwork or the climbing systems. And we will be using the facade, which is pre-finished. Imagine your wall with the windows and everything finished, painted, and just attached to the structure. That's where it will move. Outside world is already doing this. So that's the focus what, as a contractor, with considering all our challenges, the cost issues, the acceptability of the user, this is where we think the market will move in terms of commercial and residential sector. So now quickly going through the design, I think I wouldn't spend too much time, but one thing to be focused, or where L&T spends most of the time, is it's not just one thing. It's not just cost, it's not just design, it's just not quality. Everything has to work together, especially what your end user or the customer wants, and then only a big design is going to fall through. So what we will look at as how the technology is running through, right? The design, actually everywhere the design gets questioned more and more, and what we are currently doing is the emulative design. And what does that mean? For engineers is, once the building is done, constructed, it is going to emulate the behavior of your conventional system. And we have done extensive studies, extensive in-house test programs, full height tests, to showcase that, to assure that that performance is achieved, that when my joints are done, that system is going to behave similar, right? The welded and bolted connections is a different area. We are not there yet. We have several in-house and outside approvals with all leading premier education institutes. So you should be at comfort. This is not a new technology anymore, right? We have been dabbling with it for last 10 years now. And the working functional examples are there in front of you, whether the conventional layout, whether you give the layout in terms of whatever technology specific layout. Like Mr. Vermaji was saying, that you have to decide first. If you do that, nothing like it. But we have been working around it also. You throw us any layout and it can be workable. Just has to have the volume and scale that we are looking at, right? This is one of the inside finished flat. Even our own engineers cannot figure out where the joints are. That's how the detailing is done. Once the flat is finished, you are going to have a same look and feel. The factories that we put up usually are at site because transportation challenges are there. We don't have that kind of infrastructure. Factories are actually project specific, so we can wrap that same factory at the end of the project and move it to the next year. But all detailing, plumbing, what details, we have extensive experience under our belt now. More than 7,000 units delivered and have been used in last 6 to 10 years. With that, where I'm going to conclude is what we are doing now in that CIDCO Navi Mumbai project, right? So this is how that Bangalore project was envisioned by the architect, and this is how we delivered that same project in here. So what we are doing in CIDCO in terms of housing, And overall quality control, I'll probably have 5 minutes total, and then we have a video at the end that we can all look at it. So quality control, now that's one thing that comes to everybody's mind, that precast jointed and how to treat the joints. Based on all my last 10 years experience here, and I have been more of a waterproofing engineer than the structural engineer, but where we stand today in terms of this technology is we don't have leakages in these buildings, right? I see seepages. Seepage is very different. Concrete, it allows moisture. So I don't have leakage. I don't have dripping water issues. We had that, but detailing has come up extensively where we are delivering buildings with a 10-year DLP now. But seepage is there, and that seepage we have to expect and deal with it. As long as you deal with it, you have a working system. So how we deal with it is the joints are treated differently. Each joint is actually done waterproofing. We are literally ponding each flat with 1 inch water for 4 hours and making sure that it behaves like a water tank. And wherever the leakage comes, we address that and move forward. But if you'll see all these flats, whatever 1500 flats that I'm currently doing, all these flats get ponded, checked, make sure that after 4 years there is no seepage below, then it's signed off by the client, and then we move forward. We have extensive setup for the external joints where we do rainfall simulations where these joints are checked randomly and make sure that the water doesn't get in. We have our own benchmark scoring system that we are doing for this precast building specifically. So when you look at the Bangalore job, it has a score of 85. For example, I'm going to deliver your job 85 or more. So that benchmark, that quality assurance system is there. So with that all experience, we started this Sidco Navi Mumbai job about a year and a half ago. It's a massive job, about 7,500 houses. It will go to about 1,500 crore, this phase that we are looking at. And what was fascinating is the speed. If you look at it, I am doing about 30 floors per month. That translates to about 8 flats per day delivered. And what we have done, I'll just quickly summarize and then go through. But it is a classic example for mass housing, what we are looking at for PMI housing type schemes, right? We have 66 buildings. All buildings have same one type of flats. That's where we did not even tender this job using conventional system. It always, right from day one, went saying at this scale and volume, we have to build it in precast. Buildings are envisioned by architect Hafiz contractor, so they're not your traditional social housing type buildings, right? If you see, there are architectural elevations, grooves, whole 9 yard was there. We had to actually sit with them for 6 months and discuss and figure out how these will be built. The factory was built there off-site, right there, maybe about a kilometer from the site location. A massive 2.2 million square foot in terms of built-up area per year capacity, and 95% plus was done in-house. And these are some of the pictures. I'm going to have a quick video at the end of it that you can go through it. But one specifically we did now, and that's where I will mainly talking here is, we said this cycle time is going about 6 to 8 days, right? On paper, we had planned about 5-day cycle time, and we were achieving 6. Earlier it was 8, it has come to 6. But we were still feeling that this is not the best of the technology benefit that what we are doing. So what we did is we said, okay, you add extra resources. Let me see what best we can do and what cycle time you can achieve. So in April, this month, we took up that challenge. We call it Mission 96, where one tower, 12-story tower with 96 flats, we actually finished it day before yesterday in 96 days. That is including finishing. Tower is handed over, 12-story tower, 96 flats, handed over to client in 96 days. And this building, to showcase the precast technology capability, was built in 36 days. So we achieved that 3-day floor cycle. That's the best what we can do. And that's the video is going to talk about in just about 2 minutes. But that you keep in mind, right? The question came about cost in the morning also. You are spending marginally extra. We hardly spent more, about 1% more than the total building cost. But you could come to that 3-day floor cycle, right? 3-day floor cycles means you are going about 2.7 flats a day. So that is possible. How you adopt it, what level you adopt it, how you look at the life cycle cost is really up to you. Now I said 2 mantras. So mechanization, we have talked enough. You are going to see that in the video also. But the next was digitization, right? That's even in line with our Government of India initiative also. L&T, since 2016, we have been doing dedicated digitization to improve productivity. You see this entire building, the BIM model was built, including the reinforcement. What you see on the right-hand side each and every single bar was modeled in that model. Once that model was ready, we never did any 2D drafting. All those production drawings for my precast element, 95% of that was generated directly through that BIM model. That's where we actually won, like the cost was recovered there itself. But subsequently, all the mold drawings, and then that each, since the BIM model was ready, we have an in-house app also that we have deployed now, that each panel gets tracked using that app. So when the panel was cast, using what concrete, at what day, when it achieved the M15 stripping strength, how many days it was stored in the yard, when it was actually erected at the site, which location, how much time it took, and what was the cost associated. Everything is being tracked digitally using this app. So at any real time, right? Usually what happens in precast is somebody writes the report, somebody looks at it next day, then flags it. By the time the senior management knows that 3-4 days have passed. But this is real time. In the evening, that panel gets scanned instantaneously. It is updated in the system. On all these records, the progress records, everything is updated real time to everybody. Whoever is involved can look at it daily. So that's where the digitization we are planning. Where it will go next is, this is the video, and I will conclude. I know I've probably overshot my time by 5 minutes, but just play the video. This is that Mission 96 video, how we built that one tower, where the technology, the precast technology at its best, what we can do, and then I will conclude. Yeah. You can run that last video. inauguration function. So thank you very much. Appreciate it. Enjoyed it.
धन्यवाद सर, बहुत ही प्रेरणास्पद प्रस्तुति। आपके द्वारा दर्शाए गए प्रीकास्ट कंक्रीट टेक्नोलॉजी के अनेक उदाहरण हमारे लिए बहुत ही ज्ञानवर्धक रहे। अगली प्रस्तुति के लिए मैजिक्रीट बिल्डिंग सॉल्यूशन से श्री सप्तऋषि भट्टाचार्य जी को आमंत्रित करती हूँ। ये द नेक्स्ट बिग शिफ्ट इन कंस्ट्रक्शन इंडस्ट्री AAC पैनल्स एंड 3D प्रीकास्ट पर प्रस्तुति देंगे।
Thank you, madam.
Please try to finish in 20 to 25 minutes.
I'll finish before that.
Thank you.
Can you, which one to change the slide?
For changing slide, I think that this one, right? Okay, please.
So, good afternoon, everyone. So, my name is Saptarshi Bhattacharya. I am here with my colleague Saurabh Nag and Abhishek Gupta. We are from Magicrete Building Solution, and I thank all the distinguished. I thank all the distinguished people here for giving us a chance. So, Magicrete, as I will show that it is a very young company. So, as people talk about startups, we are actually a startup company, but we are not really into IT sector or internet or this thing. We are in a very traditional business, and we have shown that even in a traditional construction business, profitable businesses can be made by using technology at the right time, and making sure that the right technology is used at the right time. And this presentation will also show that government's the support in this technology helps helps to make a sustainable business in construction technology. So as I will show that Magicrete, who we are basically, is it visible? Okay. We are the largest manufacturer of AAC blocks. So AAC blocks, as everyone knows, is a replacement for red clay bricks. And we started this company in 2008. The promoter started it. So as everyone knows, AAC blocks were there since a long time actually. From late 1990s it was there. But the companies who were there were selling it at a very, very high rate, per unit rate, and the consumption was very low. But the company found that in 2008 there was a support from the government, and there was a support to transfer from red clay bricks to AAC bricks, and around all the metros there was a instruction from the government that fly ash has to be used in all the bricks. So we started with that, and what happened, our company is funded by Motilal Oswal, which is one of the leading private equity players in this market. And then later on, when by 2015-2016 we were the market leaders in AAC blocks, we realized that even in AAC blocks, the time used in construction can be further reduced. And globally, when we found out that other construction things are used, like wall panels are used where no water is used, totally waterless dry wall construction is used. So we have also launched ALC panels. So as I said, in 2008 the company was started by Mr. Puneet Bansal, Puneet Mittal, Mr. Saurabh Bansal and Siddharth Bansal, who are from IIT IIM background, and they launched with a
technical aspect.
Okay, sir.
Commercial
okay.
We are not interested.
Okay, sir. So I will just move that. I will go to the technical. So we have a manufacturing plant in Jhajjar and in Navsari, our blocks plant. So the thing is that we have launched an ALC panel plant in our Navsari plant in Gujarat. So if you can run the video, actually there is a video. So in this blocks plant, we realized that world over 30%
More than a
of
decade
the,
ago, Magic Reed set out to help people build their homes better, faster and cheaper with its flagship autoclaved aerated concrete blocks. AAC blocks are lightweight, allow faster construction and offer exceptional thermal insulation, fire rating and acoustic properties. Continuing on its journey of innovation, Magic Reed once again brings the next big shift in construction technology with Magic Light AAC wall panels. These full-height wall panels have all the magical features of AAC and more. Being as lightweight as AAC makes them easy to handle and install, making construction 4 times faster than AAC blocks. Corrosion-protected steel reinforcement makes them durable and crack-free. Now do away with coping and plastering on the walls to save time and cost. Manufactured in fully automated factory, Magic Light panels adhere to IS 6072 quality standards, made in a single or double-layered steel mesh with tongue and groove. The panels can meet challenging design requirements. Its 4-hour fire rating enables thinner wall sections, saving space and delivering higher carpet area. The installation process is non-complicated. And can be executed by semi-skilled labor. MEP installations are fairly easy as panels can be chased easily. Be it residential, commercial, hotels or industrial projects, AAC wall panel technology has seen success globally. With Magic Light panels, you can trust the walling experts to bring to you the most robust walling solution of modern times. For a quick design and quote for your project, get in touch with a Magic Reed representative.
Sir, already as you have seen in this presentation, this is 3 times, actually it is a 3rd generation wall which we call it. It is 16 times faster to install. And this comes in 600 mm and the height can be from 2 meter to 4 meter height, and the thickness of the panels can be from 75 mm to 200 mm thick, and it does not require any water to install. So it has got a tongue and groove joint between 2 faces, means 2 sides. One side is tongue, one side is groove, and it can be just put together. And if we want to have a joint which is permanent, we just use thin bed jointing motor to fix the 2 panels. And this, so that this can be used in external, 150 mm to 200 mm walls can be used in external also.
What is penetrate, water penetration?
Sir, because this is just, yeah, sir, because these ports are not interconnected, so the water does not, there is no capillary action in this panel, so it does not go up. So there will be little bit of water absorption, but it does not go from one side to another because the ports are not interconnected. And the other thing is these panels have got metal iron reinforcement inside the this. I mean there are two types of panel. If it is 75 mm thick panel, it will have a single layer of reinforcement. If it is a 100 or more than 100 mm, there are two reinforcements in iron, which is 5 mm thick.
What is the density of the material?
Sir, sir, the technology is, it is made of cement, sand, and some aeration agent we add to it, because it is just like AAC blocks we make. And the thing is that as far as density is concerned, it is similar to AAC blocks. It will be from 550 kg to 650. No, there is no fly ash. If we use fly ash, there is a chance of shrinkage crack. So because when we use AAC blocks, we use a coping bond to avoid dry shrinkage cracks which come because of fly ash. So here we don't use this fly ash, we use sand.
You are not a civil engineer.
No, I am not.
That's why you are not able to answer.
चलिए quickly wrap up करिए, please.
हाँ सर, सर the other thing, so as I said that the weight is not very much. It is 55 kg per square meter for a 75 mm thick wall, and around 54 kg in 70. Sir, it will require 2 to 3 people to lift 100 mm. Sir, एक आदमी तो सर नहीं उठा. No, so for that we have a trolleys at site, sir. We have trolleys to move from one side to another side. Yeah. Sir, as I said, for porosity, all the ports are not interconnected in this. The ports are not interconnected, so the water penetration does not happen from one side to another.
चलिए आगे बढ़िए.
हाँ सर, हमारा टेस्ट रिपोर्ट है सर. So AAC blocks में होता है, but because AAC blocks में सर होता है, but here नहीं AAC external में नहीं होता. नहीं. So here, as I have shown that fire rating इसका around from 3 hours to 4 hours होता है. हाँ. हाँ. So and sound का जो है, it is from 40 dB STC is there, and as far as because at the same thickness we are getting more area, floor area, because the thickness is less. So if we are using an AAC block compared to AAC block, the thickness is less in this thing, ALC wall. So for aeration we are using aluminum powder. So we are using fine sand, cement, and aluminum powder. So it is 70% is sand only. So we have a mold. So if I can show the video, हाँ इसमें यार, yes, yes. सर इसमें मैं वीडियो दिखा सकता हूँ if I can. Sir, if we compare with our other other way of other walling product which are there, so if we see, it is a lightweight material, ALC panel, because the weight of a burnt clay brick is around 185 kg per meter square, and the dry density is quite less. It is 550 to 650 kg per meter cube, whereas in red brick it is 1950 kg per meter cube.
देखिए ये समझ में आ गया. It's quite similar to the AAC block.
Yes.
The properties are quite similar. It will be lightweight, acoustic and thermal properties similar to that.
Yeah.
The question was about water penetration permeability. If you have anything specific regarding that, we are talking about it. Otherwise, it's finished.
So water.
Why are we go on? Please proceed to further slides.
Okay.
Finish. We are already exceeding the time.
Sir, for thermal, actually the one of the most important property of this is the thermal conductivity of the.
That is understood, bhai. Please proceed. We are, let us go ahead. That is understood.
Okay.
ऑटोमेटिक है वो, तो जब एयर एंड ट्रेंड होगी तो होगा ही वो सब। तो चलिए आगे चलिए, और कुछ है तो बताइए, नहीं तो वी वाइंड अप।
So the other product we have is 3D modular precast technology, where we are manufacturing the whole walls, not only the wall, the whole pods, which we call the pods in the factory itself. So we are using this product in, right now we are using it in Ranchi. We have won a GHTC challenge which was there. So this is being used, so as if I can show it here. So sir, the thing is, in 3D, the most of the things which are casting is done in the factory itself, and at site only we are attaching the pods at the site. So on site only erection, connection, and 10 to 20% finishing is only done. So huge amount of time saving is done by using this 3D method. And the other thing is the labor cost, material waste is reduced, then higher quality structure is made, and it is quite flexible and adaptable. Sir, the
फोटोग्राफ्स वगैरह हैं तो दिखा
Yes, sir.
दीजिए, पिक्चर्स हैं तो दिखा दीजिए कुछ।
sir, तो वीडियो चला दीजिए ना, 4th वाला। नहीं, ये वाला, ये 3D वाला हमने किया। अभी it is ongoing project. Sir, how the construction is done? How the construction is done? So as I said, these are the advantages of using, because steel processing, I mean this is the process flow. Advantages are it is एक पीछे कर देने का. Advantages are like in a single cast we have monolithic element, no connections are there, small working space and predefined mold core. So as I showed in the video, sir, and as far as technology is compared, cost wise it is little costlier, around 10 to 15% costlier, but at we have seen at 5 lakh square feet or more, it breaks even with conventional technology and the cost becomes same. Yeah, so I would conclude. So the thing is, the main advantage in this is it is very fast construction as far as 3D construction is this volumetric construction is concerned, and most of 90% of the labor is used at the factory, so safety is also is an issue, and safety issues are also taken care of. And if it is a similar type of building which is repeatable at that place, our cost comes down and construction is quite fast. So we have a production capacity of 1,20,000 metric ton at Navsari and 60,000 metric ton at Jhajjar, and we are also coming up with new plants at Wada and in Maharashtra. So with this is my final slide, sir. Thank you very much.
धन्यवाद सर। समय के अभाव की वजह से हम सीमित प्रश्न ले पाएंगे। श्रोताओं से अनुरोध है।
प्रश्न अब खाने के दौरान करें।
अच्छा ठीक है सर।
क्योंकि काफ़ी हो गया।
ओके, हम सभी प्रेजेंटर्स के आभारी हैं कि इन्होंने आज यहाँ आकर अपने विचार प्रस्तुत किया। मैं समारोह के मुख्य अतिथि माननीय महानिदेशक श्री शैलेंद्र शर्मा जी से अनुरोध करती हूँ कि वे प्रेजेंटर्स को मेमेंटोज देकर सम्मानित करें। सर्वप्रथम श्री पी.के. वर्मा जी को आमंत्रित करती हूँ मंच पे। सर प्लीज़ मंच पर आकर मोमेंटो लें। धन्यवाद सर। आमंत्रित करती हूँ श्री अमित बर्डे जी L&T से कि वे मंच पर आकर मोमेंटो ग्रहण करें। धन्यवाद सर। अब आमंत्रित करती हूँ श्री सप्तऋषि भट्टाचार्य जी मैजिक्रीट बिल्डिंग सॉल्यूशन से कि वे कृपया मंच पर आकर मोमेंटो ग्रहण करें। धन्यवाद सर। कृपया ध्यान दें, कुछ प्रशासनिक कारणों से लंच के बाद के टेक्निकल सेशंस डीजी कॉन्फ्रेंस हॉल फर्स्ट फ्लोर निर्माण भवन में होंगे। CPWD के सभी वरिष्ठ अधिकारीगणों तथा सभी प्रेजेंटर्स से निवेदन है कि आप कृपया लंच के बाद डीजी कॉन्फ्रेंस हॉल फर्स्ट फ्लोर निर्माण भवन के लिए प्रस्थान करें। अन्य सभी श्रोताओं के लिए आज के टेक्निकल सेशंस CPWD के ऑफिशियल यूट्यूब चैनल पर लाइव प्रसारित किए जाएंगे तथा CPWD के ऑफिशियल सोशल मीडिया हैंडल्स फेसबुक, ट्विटर और इंस्टाग्राम पर इस प्रसारण का वेब लिंक शेयर किया जाएगा। देवियों सज्जनों, लंच की व्यवस्था मेन एट्रियम ग्राउंड फ्लोर और फॉयर फर्स्ट फ्लोर में की गई है। अगला टेक्निकल सेशन 3:15 पर निर्माण भवन में शुरू होगा। धन्यवाद। हाँ, यहाँ पर कुछ